Hello, ladies and gentlemen, welcome back. It's Matthew Farrow here still, and we are going to continue with our solutions to the virtual assessment questions. And in this video, we're looking at the 3A, which is one of the applications of differential calculus. We want to find the critical values of critical points of this given function. So let's get right into it. So first and foremost, what do we mean by critical points of a function? So given a function, generally let's say a function f of x, the critical points of f of x are the values of x for which the derivative of f of x rather, that is f prime of x, is either 0 or undefined. So that is the definition of critical points. So if we intend to find the critical points of a function, so the strategy is take the derivative and check or verify the values of x for which that derivative you have gotten is either equal to 0 or undefined. So let's do the same thing with this given function. So this is a quotient of 1 plus u and u squared plus 4. So we are to use the quotient rule. So using quotient rule, and what does the quotient rule say? Quotient rule says if we have a function y to be a quotient of two functions of x. Okay, so let's say y is a function of x itself, then the derivative of y with respect to x is v du dx minus u dv dx all over v squared. So in shortened form, that is vu prime minus uv prime over v squared. So in this case in particular, we identify our u of x to be what is on top, 1 plus, this is a bit tricky. So I'm going to change my u to be capital U. Okay, so the capital U to be 1 plus u, and v of, so this time around it's not u of x, it's capital U of small u. Okay, I could use another letter, but I want to remain with u and v. So u is equals to 1 plus small u, and capital V of u is equal to u squared plus 4. So we are going to need the u dx, now the u, and the v du. So, or in other words, let me use u prime and v prime. So the derivative of 1 plus u is just going to be 1, because the derivative of 1 is 0, and the derivative of u is 1. While the derivative of u squared plus 4 is 2u, because the derivative of u squared is 2u and the derivative of 4 is 0. So to use the quotient rule, it means we just want to do this times this minus this times this divided by v squared. Okay, and then in this case we are going to have, therefore, the y dx, let's keep using blank, the y dx is equal to the red now, that is 1 times u squared plus 4 minus the blue, which is 2u times 1 plus u, everything over v squared, which is u squared plus 4 squared. And if we simplify that, that gives us u squared plus 4 minus 2u minus 2u squared divided by u squared plus 4 squared. And all in all, that gives us 4 minus 2u minus u squared. Now, all over u squared plus 4 squared. Okay, so we've gotten the derivative of so this should be dy du, not dy dx, because the independent variable here is u, not x. Now that we've gotten the derivative, the critical points are therefore the values of u, so the value or values of u for which this expression star is 0 or undefined. And since it is a rational function, this derivative is 0 when the numerator equals to 0. Okay, so y prime of u is 0 if and only if the numerator 4 minus 2u minus u squared is equals to 0. In other words, we are considering u squared plus 2u minus 4 equals to 0. So if I either say multiply through by -1, or I transfer everything to the other side. So all we just need to do is to solve this quadratic equation. So let's use the quadratic formula with a equals to 1, b equals to 2, and c equals to -4. Then it means the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. So then that is equal to -2 plus or minus square root of 4 plus 16 over 2. Okay, so if I want to be smooth, I can say 4 times 4. Why am I doing that? I want to factor out the common 4 there. So by the time I factor out the common 4 and take it out of the square roots, it's going to be plus or minus 2 square root of 1 plus 4, which is 5. And that is all over 2. So if 2 is factored out as a whole, so we have -2 plus or minus square root of 5. -1 plus or minus square root of 5 all over 2. The 2 cancels out, and we have u to be equal to -1 plus square root of 5, or u equals to -1 minus square root of 5. So these are the values of u for which the derivative is 0. Can it ever be undefined? That would have been the values of u for which the denominator is 0. But when you look at this denominator, u squared plus 4 squared, there is no value of u for which this is equal to 0. So because when you look at it, it's looking at u squared plus 4 squared equals to 0. Take the square root of both sides. U squared plus 4 equals to 0. U squared is equal to -4. And here, because we are dealing with real numbers, there are no values of u for which that will be satisfied. So in this case, we have that, therefore, the only critical point of our y of u are u equals to -1 plus square root of 5, and u equals to -1 minus square root of 5. And that is all I have for this particular video. So when I come back, we're going to move forward into the next question, which is about taking the derivative of an inverse trigonometric function. And until then, enjoy yourself and enjoy mathematics. Bye.